I attended the presentation in the physics department at Stanford, and it was about bootstrapping mesons. Now, just to get this right out of the way from the beginning, I'm not going to go into the weeds of theoretical physics here. That's not the goal. That's not my goal. That's not the goal of this podcast. It's certainly not part of the business of Orange Capital Partners. So this is way too in the weeds for any of those things. However, why is this still interesting, and why am I doing an episode about this? And the reason it's interesting is actually for the following reason. I think bootstrapping a theory, like for example mesons, which is generally the idea of bootstrapping hadrons, which is again developing a theory about subatomic particles that are exposed to one of the four forces that the theoretical establishment of physics thinks are playing a role in elementary particles. Bootstrapping a theory, in essence, means trying to build something out of certain axioms that don't depend on any kind of observation or any other assumption. So basic axioms, for example, symmetry, for example, chirality, like it's left-handed versus right-handed, the spin is going this way versus that way, things along those lines. Now, again, I don't want to go into the weeds. It's not important. I'm not a subparticle physicist. My job is to generate wealth, and I decided a couple of years ago to do this with artificial intelligence. I think it's a huge opportunity for mankind to create beautiful things and also generate wealth. And the reason I believe so is actually in some ways really well described in Richard Sutton's essay, The Bitter Lesson. And what I found fascinating is sort of this interplay between bootstrapping a theory, generating knowledge out of literally nothing with a few axioms on the one hand, and on the other hand, having one of the leading AI scientists of our time saying that we shouldn't build too much on knowledge and we should more focus on the methods that approximate reality. We don't have much of a clue of what reality looks like. And while that has some philosophical implications, I think the most interesting part of this conversation is the question, where do we as investors and entrepreneurs and business people draw the line between knowledge and learning? This is not even on podcast. It's May 9, 2024. This is Krim Delco. For the day, the fund is down 1.6%. The market's up 0.5%. For the year, we are down 18.6%. The market is up 9.2%. We're on the firm at 27.8%. So let's talk about the presentation. First, it's part of the events series that I'm attending, a seminar series in physics, bootstrapping mesons. That's a theory that is probably about 50 years old. The idea is bootstrapping. It just means that the way I understand it is in physics, generally, there are things that we observe and we can deduct theories from there. We can do inductive theory, which is we can, let's say, understand how an apple falls from the tree and then take that as an induction for other theories, like, for example, how a missile, is guided through air, things like that. So there's this and that, but in general, in physics, I think the most interesting parts of physics have been always those where you bootstrap a theory, like general relativity, where you don't see anything. You're completely oblivious about what you actually see, and you work with basic axioms, typically mathematical axioms such as symmetry, chirality. Like you make certain assumptions, and then you start working with the system. You start developing a system and maybe eventually a theory that can then lead to predictions that might be tested. So that's generally what bootstrapping is about. And the reason I find this fascinating as a conversation is because we here at Orange Capital Partners, our purpose is to generate wealth by investing in fundamentally new concepts and engineering practices. We decided to do this in the field of AI because this is the opportunity of our lifetime, of our careers. everybody gets one or two of those. We actually were lucky enough to get two of those. One was the internet in the 90s, and now there's AI. And I want to connect bootstrapping and the idea of creating knowledge with Richard Sutton's essay, The Bitter Lesson, that I discussed yesterday at length, and sort of hopefully conclude in where we think wealth will be generated in a more general way. Doesn't mean that this is not investment advice, and we don't. It's very difficult to pick the right winners, but at least if you know roughly what ingredients are necessary to develop a technology like AI that actually really delivers massive progress for humanity and therefore also generates wealth. In order to do that, I think it's worth understanding a little bit this dichotomy between generating knowledge and the bitter lesson in Sutton, which is focus on compute and learning and don't waste too much time with knowledge. In fact, don't even encumber your mouths with knowledge. So let me first dissect both of them. What is bootstrapping a theory? It's literally creating knowledge out of where there's no knowledge. And there is also no induction and deduction available, particularly things where we don't see, we can't do experiments, we can't understand. Let's say it's very difficult to do an experiment to test the multiverse theory. And as the way I understand it, Everett, when he came up with that, he kind of did bootstrapping, right? He looked at the Schrödinger equation and the mathematics around, the Heisenberg uncertainty principle and things along those lines, and he just sort of took it to the next level. He was rigorously following the theory, and he got to the conclusion that there has to be something that observes our universe from the outside, and that something is another maybe parallel universe, and that in that sense you have this collapse of the wave function, which just simply means in our universe this is the path of the wave function, and in other universes, in the infinite amount of other universes, it has other trajectories, and in the whole of multiverse actually things are very deterministic. It's just that we only see very little of the multiverse, and therefore we have this probabilistic view of the world. Just to be clear, something that we can't see but that we can actually grasp is all over us. For example, gravity is one of those things. We can't see it, we can't feel it. Excuse me, of course we can feel it, but we can't. It's not like there's no science saying this is gravity. We had to come up with it in painstaking physics over centuries almost, with people also being prosecuted for it and all those kind of things. We don't understand. We can't see what's going on in the sun, nor do we have a good sense for the actual physics that are going on there in terms of the ability to go in there and look at it. But we still have a good theory, a good explanation, and that's because we use this concept of bootstrapping. So knowledge is valuable. Certainly, we like to have knowledge, right? Let's establish that. And physicists, theoretical physicists, are at the forefront of this. But this type of knowledge, this bootstrapping style of knowledge creation, happens everywhere all the time. This is not just a physics thing. It just happens to be more maybe spectacular in physics. Now, let's go to Richard Sutton's The Bitter Lesson. What is Richard Sutton saying in The Bitter Lesson? He's saying that what works in creating intelligent machines, what has worked so far is search and learning. And both of these vectors are scalable through compute. That's why they work. And having explicit knowledge conveyed to the machines is sometimes gets you short-term gains, but doesn't really help in the long run. So focus on learning and develop methods that help you approximate reality. Reality is too complex. Don't try to understand with our human approach what reality is. Develop methods that then approximate this reality. This is the dichotomy. On the one hand, we have knowledge. On the other hand, we have almost a reductionist way. Let's take the knowledge out of the system and just leave it sort of in its pure form, data-driven learning, and that will eventually lead to success. Now, we at Orange Capital Partners, we are dedicated towards investments that follow that line. NVIDIA and Tesla are two examples. We have large data sets. We have a lot of compute. We have very general models. We have very little actual explicit knowledge being conveyed to the machines. This is where we stand. This is what we expect when we talk to, let's say, Tesla. This is what we expect to hear, and we hear a lot of that. Now, it's not 100%, and that's one of the big questions as investors or engineers, for that matter, is, okay, we can't always wait that long, right? We have to maybe sometimes use a shortcut just to get stuff done, right? Now, I would say that the answer to that problem is eventually iteration through simulation. Because what it all boils down to, in the end, is to have more shots on goal, to try more things, to try and fail, and to find ways to do that at low cost. And the best way to do that at low cost is through simulation. So invest in simulation, represent reality in the best way you can, and then develop methods, such as reinforcement learning methods, to approximate the best trajectory within that reality. That's kind of the way we see it. And knowledge is implicit. So we are on board with Richard Sutton, and you could say at the extreme, at the actual extreme, Sutton and bootstrapping, they find each other. Because bootstrapping is generating knowledge out of axioms. Sutton says, let's just focus on search and learning. Let's just stay with learning now. Let's put search aside. And knowledge is implicit. So if you bootstrap something, you implicitly generate knowledge from that boot. It's not like there's a label or somebody told you this is what it is. Like, we come up with that, right? We come up with the theory of particle physics and the strong force and the weak force and the gravity. I forgot what the fourth one is. We have ideas about quantum chromodynamics, which is the interaction of the strong force with hadrons, such as mesons and bosons and things like that. We bootstrap that by generating implicit knowledge, in the sense that we don't explicitly decide this. We don't put definitions, or we don't put constraints on these particles. All we're trying to do is have certain axioms. Now, you could argue that that's a constraint, and there's a fine line between, okay, well, where do we humans actually set the constraints? We have to set some constraints. We can't just randomly, the concept of the beginning of infinity by David Deutsch is that we humans are a special type of intelligence because we can accelerate evolution. And in order to do that, we have to draw certain lines in the sand, right? We have to say, okay, we want evolution to go that way. We want to iterate this way, and not just randomly try all kinds of possibilities until we, over the millennia and millions of years and so on and so forth, figure out the best way to fly, and the best way to think, and the best way to be intelligent, and things like that. We want to accelerate all. That's the whole premise, right? So this is an open question. An open question I have for CVPR, for academics, for business people, Elon Musk, Jensen Huang, and others who are deeply involved in AI. Basically, you want to bet on learning. So where do you draw the line? What is knowledge that is required for deep learning, and what isn't? That's the big question. And finally, just as a side note, but I think it's an interesting question, which is, well, you're saying it's about learning and compute. Let's parse those two. What exactly is learning? That in itself requires knowledge too. So the learning itself is not a random thing that falls from the sky. We can learn through reinforcement learning. We can have different reward functions. So is that what Sutton means with develop the methods? So we have to learn how to learn. And then the compute side is we have to learn how to iterate, which is what compute is. And that we have to do it at scale, and we have to find out ways to do this even faster, which we are. In particular, if we add the potential of quantum computing, there's definitely a case to be made that we have a continuation of Moore's law. We have quantization, we have sparsity. So there's things where we can really do a lot of compute on massive data sets, which is what NVIDIA in particular is doing. Others are doing it too, but particularly NVIDIA. So to summarize, this tension between bootstrapping and Sutton, I think, is an interesting avenue to think about. As an investor, we have taken a position that we want to actually be invested in companies that are following Sutton's path, which is bet on scale, have as little explicit knowledge as possible, and follow compute. So that's fine. But then there's some philosophical questions. How much knowledge does a system need at the minimum? What's the minimum amount of knowledge you need to have an effective system that has a good chance to develop a product? So that's one question. Is there such a thing? Is there some sort of Heisenberg uncertainty for knowledge that is required to bootstrap AI? And then the question also, what is the knowledge in learning itself, and what is the knowledge in compute? Those are just interesting questions. I don't have pure answers, but you could argue that a lot of the research and engineering of the near future, next 20 years, will be about the methods, the actual methods to better learn from data, and then of course also to better express data, whether it's microstructure, infrastructure, GPUs, the memory side. So those kinds of questions, or even data structure type questions. Should we use vector databases, or should we use graphs, or what kind of representation of the data makes most sense? So those are interesting, in my opinion, interesting questions that, of course, eventually could also be solved with AI, right? You could have an approximation of what's the best data structure. You could have an approximation in what's the best sort of hardware-software relationship. So you could have those types of relationships, and those are really open, interesting research questions. And I think, just to end this episode, for new listeners, why are we talking about these things at Orange Capital Partners? And why, the Not Even Wrong podcast series is meant to give people a sense for what it feels like to run a hedge fund. So why are we talking about this? Because it helps to have a bit of a guideline, a sort of a lay of the land of where we stand and what kind of paths we're following as investors. Thank you.